Okay, so let's continue with section 4.2, and now we're going to consider tangent. So let's recall, or the graph of tangent rather. Recall that tangent of theta is the quotient sine of theta over cosine of theta. And let's note, I'm going to go over, let's do theta, sine of theta, and cosine of theta in a chart. But I'm just going to plot a few points. So let's plot theta equal to 0 radians. So sine of 0, the y-coordinate is 0, whereas cosine of 0, the x-coordinate is 1. Now let's go on to pi over 4 radians, or 45 degrees. We know that sine and cosine are the same. They're both root 2 over 2. Root 2 over 2. Now let's go to 90 degrees, or pi over 2. So the y-coordinate sine is 1, and the x-coordinate cosine is 0. Going into quadrant 2 and the 45-degree reference angle, that's 3 pi over 4. So the y-coordinate is still positive root 2 over 2, whereas the x-coordinate is negative root 2 over 2. Okay, now on to 180 degrees, or pi radians. We have that the y-coordinate sine is 0, and the x-coordinate cosine of theta is negative 1. Okay, so now let's go down to the 45-degree reference angle in quadrant 3. So that's 5 pi over 4. And we know that both sine and cosine, that is y and x respectively, are negative. So negative root 2 over 2, comma negative root 2 over 2. Continuing to the next quadrantal angle, which of course is 3 pi over 2. On the axis there, we have that the sine or y-coordinate is negative 1. Sorry, on the y-axis. And the x-coordinate is 0. Let's do a few more. Okay, so now let's go into quadrant 4. And the 45-degree reference angle there is going to be 7 pi over 4. Y is still negative, so sine is negative root 2 over 2. Whereas the x-coordinate cosine is going to be positive root 2 over 2. And coming full circle to 2 pi, we're back to 0 radians, or 2 pi equivalent. So we know that sine is 0 and cosine is 1. Okay, so what I'd like to do now is consider the graph. Let's do, what color should I use? Let's do tangent in this color of purple. So tangent of theta, we know, is the quotient, sine over cosine. So let's go ahead and take the quotient of the two numbers above in each instance. Okay, so 0 divided by 1 is fine. It's 0. It's thou shalt not divide by 0 that's the problem. Root 2 over 2 divided by root 2 over 2, of course, is just 1. Now, dividing by 0 does not exist. So that would be a vertical asymptote to the graph, and we'll come back to that. So in quadrant 2, the quotient of the 45-degree reference angle values is negative 1. At 180 degrees, 0 divided by negative 1 is 0. In quadrant 3, notice that the quotient of two negatives is a positive. So hence tangent at 5 pi over 4 is positive 1. Now going to south, 270, or 3 pi over 2, we're dividing by 0 again. So we will have a vertical asymptote to our graph there. Then the 45-degree reference angle in quadrant 4 gives us a quotient of negative 1. And coming full circle, 0 in the numerator gives us 0. So let's go ahead and plot this. So let's consider the graph. So consider the graph of, now let's do f of theta is equal to tangent of theta. So once again, theta versus f of theta coordinate axes. So theta versus f of theta. Let's do 1, 2, 3, 4 quadrants going forward. 1, 2, 3, 4 quadrants going back. Let's have this be positive 1 and negative 1. So this is pi over 2, pi, 3 pi over 2, and 2 pi. Similarly, going backwards, minus pi over 2, minus pi, minus 3 pi over 2, and negative 2 pi. Now I'm also going to note the pi over 4, the 3 pi over 4, the 5 pi over 4, and the 7 pi over 4. And I'll just put tick marks at the midpoints going backwards. Okay, so what do we have? Purple. So tangent of 0 radians is 0. Tangent of pi over 4 radians was positive 1. Tangent of pi over 2 radians does not exist because I'm dividing by 0. Hence I know that there's a vertical asymptote there. Okay, moving on to tangent of 3 pi over 4, and that is negative 1. So I have a point down here at negative 1. Tangent of pi is 0. Tangent of 5 pi over 4 is positive 1. And tangent of 3 pi over 2 does not exist because I'm dividing by 0. Hence there is a vertical asymptote here at 3 pi over 2. Note not drawn very well. Trying to do that. Okay, at 7 pi over 4, tangent is once again, has a value of negative 1. So it's 7 pi over 4, negative 1. And full circle, at 2 pi, the value for tangent is 0. So I have something that looks like, no, not drawn very well, trying. So, okay, so let's go backwards. If I go back 1 quadrant to the left, that's the same as 7 pi over 4. And 2 quadrants, that is the same. Negative pi over 2 is the same as positive 3 pi over 2, so I know that there's a vertical asymptote there. So it looks like tangent repeats every 2 quadrants. So that means that this will be, I put the positive 1 in the wrong place. A positive 1 here, 0 here, negative 1 here. And then a vertical asymptote at negative 3 pi over 2, which is equivalent to pi over 2. So we have this graph here. And then positive 1 at negative 7 pi over 4, which is the same as pi over 4. And 0 at negative 2 pi, so it looks something like so. Okay, and it looks like I got this part of this graph wrong. My point was a little bit too high, so there we are. So that looks better. Okay, so let's note something about the domain and the range and the period here. So let's note the domain has to exclude all values of theta for which the denominator is 0. That is, for which cosine is 0. So cosine is 0 on the y-axis, that is north and south, so that's pi over 2. And it looks like the distance between any 2 asymptotes here is pi units. So I'm going to add pi times any integer, positive or negative, k. So those are the exclusions to the domain. And now let's look at the range. Looks like the range is unimpeded all the way from negative infinite on the y to positive infinite on the y. Remember, just cast a shadow of the function onto the axis. So the range goes from minus infinite to positive infinite. And I said that this repeats. It repeats the same graph between any two asymptotes. So notice that the period is now pi units. So let's note. The period for tangent is p equals to pi. That is, i.e. id est, that is 2 standard quadrants. Okay, so theorem. So given either f of theta is equal to a tangent of n theta, or f of theta is equal to a cotangent of n theta, and we'll show this in the next video. We have that. The absolute value of a is the amplitude, remember. It's a distance, it has to be positive. And the period for both tangent and cotangent is pi over n, and this is corresponding to two periods. What am I saying? Quadrants. Okay, so let's go ahead and plot an augmented tangent graph. So for example, let's plot the graph of, let's do f of theta is equal to 2 times tangent of 3 theta. So we have our function f of theta is 2 tangent of 3 theta. So the amplitude A is 2. The period P is going to be pi divided by this 3 here. But remember that's, and I'll use quotations, 2 quadrants. So what do I mean by this 2 quadrant deal? So theta versus f of theta coordinate axes. Okay, so let's split this up into 1, 2, 3, 4 parts going forward, and 1, 2, 3, 4 parts going backwards. My amplitude is now 2. So going up 2 and down 2. Okay, so usually it'd be 2 pi, but I'm going to have to divide by something. Pi over 2 divided by something, pi divided by something, 3 pi over 2 divided by something. Is that something still 3? Well, yes, because notice, dividing each element by 3, so the same as I would otherwise, gives me the fact that 2 quadrants here, the length of 2 quadrants is indeed pi over 3. Okay, so going backwards, those would correspond to minus pi over 6, negative pi over 3, negative pi over 2, and finally negative 2 pi over 3. So technically you can evaluate the augmented period the same way. Okay, the difference now, so the vertical asymptotes, what color shall I use for that? Let's use orange. So the vertical asymptotes were at quadrant 1 and quadrant 3 for tangent. So that is not on the y-axis. They are at the first tick mark and at the third tick mark. And there are two quote-quote quadrants between each asymptote. And I know that tangent of 0 is 0. So I start at 0. Normally, halfway up I would go to 1. And then I would approach the asymptote. However, it's twice as tall, so that means this is just going to be stretched by a factor of 2 vertically. So similarly, I would normally start at -1, 0, and 1 for tangent. But what that 2 is going to do is it's going to stretch this -1 to -2. 0 stays in the same spot. +1 stretches to +2, and now I get a tangent function that is twice as tall as the original tangent function. So it would be -1, 0 normally. But now it's going to be -2 and 0. So twice as tall. And going backwards would be the same. Okay, so does everyone understand, hopefully, since I really can't ask you virtually, but I'm hoping this is making sense. We're plotting tangent and just making him now twice as tall, like we did with the functions a couple days ago. Okay, so there we are, etc. Okay, so let's note what the domain and range are for this one. So the domain are those values of theta, or they exclude those values of theta for which the denominator is 0, or those values of theta where I have vertical asymptotes. And that looks like to be pi/6 plus the distance between any two asymptotes is pi/3, so any integer multiple of pi/3 plus or minus. Okay. The range, of course, for tangent is all real numbers. So let's write it as all real numbers, like so. Okay, so let's move on to one more just for fun. I know this was a long section, so let's wrap it up. Let's see, how much space do I have? Okay, so for example, let's plot the graph. Let's do f of theta being equal to negative tangent of 5 theta. Okay, so if I have that f of theta is negative tangent of 5 theta, I know that the amplitude is 1. I know that the period for 2 quadrants is pi/5. And I know, so let me make sure that I know that's 2 quadrants or tick marks. And what about this negative sign in front? That means it's a reflection about the x-axis. So let's go ahead and plot that. So theta versus f of theta coordinate axes. Let's see, how much room do I have? Okay. So theta, f of theta, let's go 1, 2, 3, 4 parts, and 1, 2, 3, 4 parts to the left. My amplitude is 1. Okay, so this would normally be 2 pi for 4 quadrants and pi for 1 quadrant, but we're dividing that by 5. Okay, and this would be pi/2, which we're dividing by 5. And 3 pi/2, which we will divide by 5 as well. Those correspond respectively to negative pi over 10, negative pi over 5, negative 3 pi over 10, and negative 2 pi over 5. Okay, so the asymptotes for tangent are at the first quadrant and the third quadrant, going both forward and backwards. Okay, so let me do different colors here. Tangent of 0 is 0. It normally goes to 1 at the pi over 4 reference angles going forward in reading direction, or negative 1 at the pi over 4 reference angle going backwards, or left anti-leading reading direction. So the graph of normal tangent would look something like so in each quadrant, so it repeats. Sorry, for every 2 quadrants, because the period is 2 of these tick marks, which for us right now is pi over 5. Okay. Once you get used to plotting these, they should be a lot easier. Might seem cumbersome for the time being, but I assure you, the more you do it, the easier it gets. Okay, but the actual graph of tangent in this example is minus. So what that means is I'm going downhill in reading direction instead of uphill. So I still start at 0, but the negation of positive 1 is negative 1, and the negation of negative 1 is positive 1. So what happens is I reflect this about the x-axis, and I get this graph for tangent that is going downhill in reading direction. That is, it's negative for tangent. And it repeats every 2 augmented quadrants. Okay, so let's go ahead and find the domain and range here. So the domain has to exclude all values of theta for which cosine is 0. And in this example, the asymptotes are at pi over 10, and the distance between asymptotes is pi over 5, so I'll add any integer multiple of pi over 5 to that. And these are the values of theta I must exclude, and of course, the range is still all real numbers. Okay, I hope this is making sense.